Hey there, and welcome. Today, we're going to put on our detective hats and solve a different kind of mystery. This one's all about numbers, patterns, and a little bit of future telling. We're cracking the case of regression, the math detective.
So let me ask you this. What if you could predict the future? No, I'm not talking about lottery numbers, though that'd be nice. I mean something almost as useful. Imagine knowing exactly how many customers you'll have next week, or how well a student might do on their next test.
You might think that sounds like some kind of magic, but it's not. It's a really powerful tool that, real-life math detectives use every single day. And by the time we're done here, you'll know exactly how it works.
So what is this master tool? Well, it's called regression, and its main job is to predict what we call continuous outcomes. That's just a fancy way of saying things you can measure on a sliding scale, not just count. Think about things like temperature, height, or time, where the values can change smoothly.
At its heart, regression is all about finding patterns in your clues. Let's say you're running a lemonade stand. You start to notice a pattern, right? The hotter it gets, the more lemonade you sell. Regression is the tool that lets you figure out exactly how strong that connection is. It turns your gut feeling into an actual predictable formula. So the key takeaway here is, if the answer you're looking for is a number that can go up and down, like how tall a plant will get, how many minutes homework will take, or the number of visitors at a clinic, regression is your go-to detective tool. And yeah, it's perfect for our lemonade stand.
Okay, so like any good detective, we've got more than one trick up our sleeve. Regression has a couple of key methods for finding patterns, and they both basically revolve around drawing lines through our clues. Let's break down the main types. First up, we've got simple regression, and it's just as straightforward as it sounds. Our detective uses only one single clue to make a prediction. For our lemonade stand, that's just using the temperature to guess our sales. But to get a way better prediction, we can use multiple regression. Now our detective is looking at a bunch of clues all at once, like the temperature, the day of the week, and whether it's a school holiday. Makes sense, right? More clues usually lead to a much smarter prediction.
But hey, not all mysteries have a numerical answer. Sometimes a detective just needs a simple yes or no. So what if that's the kind of future we want to predict?
Well, this is where a totally different tool comes into play, logistic regression. And what's really cool is how you can picture the difference. While linear regression draws a straight line to predict a number, logistic regression draws this slick S-shaped curve, and its job is to predict which of two boxes something falls into, like yes or no. So, instead of asking how many, logistic regression asks, will they? Will a student be absent tomorrow? Will a patient actually show up for their appointment? Will a customer click that buy button? If the answer is one thing or the other, logistic regression is the right detective for the case.
All right, pause. Before we go any further, we need to talk about the number one most important rule in the Math Detective's Handbook. Seriously, this is the one thing that separates the rookies from the pros, and it is absolutely critical to get this right. Let that one sink in for a second. Just because two things seem to be connected, it does not automatically mean one is making the other one happen. This is a classic trap, and so many people fall for it.
Here's the perfect example. Correlation is just a pattern. In the summer, ice cream sales go way up, and so do visits to the swimming pool. They are definitely correlated. But causation? That's cause and effect. Buying ice cream doesn't cause you to go swimming. The real cause of both is the hot weather. So regression is fantastic at finding correlations, but it can't prove causation all by itself. Always remember that.
So you've run your analysis, you've found a pattern, and your model has drawn a line through the data. Now what? Well, now it's time to learn how a detective actually reads these clues to figure out what they really mean.
Let's start with a number, just a simple number, like 2. In the world of regression, a single number like this is our first major clue.
This number is called the slope. It's basically the tilt of our prediction line, and it's incredibly powerful. A slope of 2 in our lemonade model tells us that for every single degree the temperature goes up, we can predict we'll sell 2 more cups of lemonade. It tells us the power of our clue.
The other key part of our line is the intercept. Think of this as our starting point, what our model would predict if our clue was 0. So an intercept of 10 means we'd predict 10 sales at 0 degrees. Now that might not always be realistic, I mean, who's buying lemonade when it's freezing, but it gives our prediction line a crucial anchor point.
Okay, so we've got our prediction line, but how do we know if our detective work is actually any good? How well did we solve the mystery? For that, we look at something called R-squared. The easiest way to think about it is like a report card for your model.
R-squared is just a percentage that tells you how much of the mystery your model successfully explains. A high R-squared, say 90%, is like getting an A+. It means your clues are doing a fantastic job of predicting the outcome. But a low R-squared, like 20%, well, that means your model is pretty much just guessing.
So the bottom line is simple. A high R-squared means you found a strong, reliable pattern. A low R-squared means the relationship is pretty weak and you might need to go find some better clues for your investigation.
Look, even the best detectives make mistakes. No prediction is ever going to be perfect. So the final and really important step in our investigation is to look closely at our mistakes to see what they can teach us.
These mistakes have a name. They're called residuals. A residual is simply the difference between what your model predicted and what really happened. A good detective wants to see residuals that are small and totally random, with no obvious pattern. If you start seeing a pattern in your mistakes, like, hey, we're always overpredicting on hot days, that's a huge clue that your model is missing something important.
And there you have it. Just like that, you've put together a complete math detective toolkit. You know what regression predicts, the difference between simple, multiple, and logistic. You know the golden rule of correlation versus causation. And you know how to read all the key clues, like the slope, the R-squared, and the residuals.
You are now officially equipped to find patterns and make predictions in the world all around you. So, I guess the only question left is this. Now that you're a math detective, what mystery are you going to solve first?